Hello students, let us solve some repeated questions in JEE examination for 2026. So first of all, let's analyze this sum. Here it has been given that alpha beta gamma belongs to R, and then x squared sine alpha x plus gamma minus 1 into e to the power x square by sine 2x minus beta x equal to 3. So we have to find the value of beta plus gamma minus alpha. So then what we'll do here, first of all, what we have to see that in this case, if we see that denominator is coming 0, this denominator is coming 0, so answer is 3. It means finite number and denominator is coming 0, therefore numerator has to be 0. If numerator is 0, so in this case what we will do, so x square sine alpha x plus gamma minus 1 into e to the power x square. So if we make numerator 0, because it should be 0 by 0, understand this, denominator 0, so numerator has to be 0 by 0, then only it will be coming indeterminate form and we'll get some finite value. So numerator has to be 0. So under this situation, what we'll do, put x equal to 0 here, put x equal to 0, so we are getting 0 plus gamma minus 1 into e to the power 0, it means 1 equal to here 0, so gamma equal to 1, we are getting gamma to be 1. Now how we'll proceed? Now you see one thing, that here the limit converted to, if we put gamma equal to 1 here, then limit converted to x square sine alpha x by sine 2x minus beta x. So these type of sums are very common for the entrance examination. So now what we'll do, we'll multiply by x square, it means limit here x tend to 0, so we are multiplying by x, so x cube sine alpha x by x. So remember one thing, we are multiplying alpha in the numerator denominator, and whenever we'll get the opportunity to put the formula, it's the best way to use the formula, because using formula you will make your sum easier. And sine 2x what is called, that is the series, that is 2x minus 2x whole cube by 3 factorial plus 2x whole to the power 5 by 5 factorial up to infinity minus beta x. So finally we are getting this. Now what we'll do now here, equal to limit x tend to 0. So in this case we are seeing that sin x by x is coming 1, so numerator is coming x cube alpha, denominator, if I just utilize here that single power of x, if we take common single power of x, we are getting here what, that is x into 2 minus beta, there is no square power of x, then directly we'll go to the cubic power, minus 8 by 6 here x cube plus all the higher power, because we need only the x cube in the denominator, okay, to get the finite number. So in this case x to the power 5 by 5 factorial equal to 3. So from all the higher powers, everybody, all these higher powers continuation will be 0, and since numerator is the x cube, the highest degree is x cube, and the value is 3, and the value is 3, therefore this 2 minus beta should be 0, therefore we are putting 2 equal to beta, and what is coming here, in this case we'll put alpha by minus 8 by 6 equal to 3, so alpha equal to minus 4. So we got alpha beta gamma. Once again, this is beta, this is gamma alpha, and this is gamma is coming 1. Now let's put the value, that alpha plus beta, what is there, alpha beta plus gamma minus alpha. So in this case I am putting the value, that beta plus gamma minus alpha, finally this is coming 7. So in this case answer is coming first option. I'm going to the next sum. This type of sums are very frequent for the JEE examination, and repeated type is there. And nowadays you just notice one thing, in entrance examination questions are coming on series. So here definitely we can use the series of cos x. So otherwise you can by differentiation method also, it's better to use the series of cos x. So what we'll do now, so let us apply the series of cos x. So limit x tend to 0, cos 2x का formula क्या होगा, 1 minus 2x whole square by 2 factorial plus 2x whole to the power 4 by 4 factorial continuation plus a into 1 minus 4x whole square by 2 factorial plus 4x whole to the power 4 by 4 factorial continuation minus b whole divided by x to the power 4. It means all power before x to the power 4 should be 0 to maintain the finite value, because here it has been given that it is a finite value. So what I'll do in this case, just only two variables, two constant a and b you have to find out. So much calculation is not needed. First of all, in this case we are extracting all the power before x to the power 4 is 0. Therefore, what is the single power? 1 plus a minus b plus what is the double power? What is the power of x square? In this case, we are seeing that x square double power. In this case, 2 square is 4. This is 2, that is 2x square. And one more x square power is here. This is the x square power. So this is coming 8. 16 by 2, that is 8. So if I just extract the power of x square, so what we are getting? Minus 2 minus 8a x square. So in this case, this is also 0. This is also 0. Power of x to the power 4 is finite, so not needed. So what I will get it, a minus b plus 1 equal to 0. And what I am getting, minus 2 minus 8a equal to 0. Therefore, a equal to minus 1/4, and putting the value of a, we are getting b equal to 3 by 4. So everybody, finally you are getting a plus b equal to minus 1/4 plus 3/4, which is coming half. So final answer is half. The option number C is the right option. Now I am going to the next sum. This is another very good sum. So for this type of sums, just by seeing what to do, this is 1 to the power infinity का format, 1 plus fx whole to the power gx का format. So in this case, what we'll do, everyone, here f2 is given, f dash 2 is also given, and then the number of times the graph y meet the x-axis. It means just by seeing the sum, you have to decide exactly what I'll do. So here what I'll do, first of all, we have to get the value of alpha from the limit. Now cubic equation solve and find the number of roots, find the roots of the cubic equation. That is the main target, main strategy for our sum. So always whenever you'll see any sum, you have to select your problem solving strategy. So what I'll do here, in this case, limit x tend to 0, that is f of 2 plus x whole to the power 3 by x equal to e to the power alpha. We know that 1 plus fx whole to the power gx, limit x tend to 0, is e to the power fx into gx. So this format will utilize. Now we'll use this format. So what we'll do, that is limit x tend to 0, e to the power 3 by x into f of 2 plus x minus 1. That is 1 plus fx whole to the power gx. That is coming to be e to the power alpha. This is 1 to the power infinity form actually. This is the form of 1 to the power infinity. Now what I'll do, just by seeing the sum, in this case, what I am thinking, that the simple apply the L'Hopital's in the power. In this power, everybody apply the 0 by 0 form called L'Hopital's theory. So in this case, if we apply the L'Hopital's theory, what we will getting, limit x tend to 0, e to the power 3 f dashed 2 plus x. Okay, denominator x is 1, so this is equal to e to the power alpha. Now since there is no any chance of getting denominator 0, we can directly put the value of x. Here x is 0, x tend to 0, therefore f dash 2, and already f dash 2 value is given to us. We are given f dash 2 value, f2 value, everything is given to us. Though what will I do here? That is limit x tend to 0. Already 0 limit is not needed at this moment. So e to the power f dash 2, what is given here? F dash 2 is 4. So e to the power 12 equal to e to the power alpha. So finally we got the value of alpha. Alpha equal to 12. Finally, everybody, we got the alpha equal to 12. Now I am going to just put the value alpha equal to 12 here, and we'll solve the cubic equation. There is no any another way, I think. So we are getting y equal to 4x cube minus 4x square minus 20x, alpha equal to 12. I am putting alpha equal to 12. I am seeing that 4 is coming common, and everyone, nowadays cubic equation is very important. Cubic equation is regularly coming. So be ready with the cubic equation, that is return trial method. So in this case, if we put x equal to -1, we are getting 0. And always remember, in case of cubic equation, you'll put x equal to +-1, +-2, +-3. Further it's not needed, and or half, +-half. So in this case, we are seeing that x plus 1 whole square into x minus 3. So roots are x equal to -1, and 3. So 2 distinct root. So answer is 2. So therefore final answer is option number C. So everybody, this type of sum is regularly coming. This type is regularly coming. Be ready with this type of sums. Let's go to the next sum. So this is another type question. Here it has been given that fx equal to limit x tend to infinity. So fx is this. You just see one thing, just simple polynomial part of in the numerator denominator. The maximum power is x square, and here it is 3x minus 1 whole to the power x by 2 by root over 3x plus 2 whole to the power x by 2. So if I calculate this root over portion in the numerator denominator, it will be easier for us to calculate. So 3x minus 1 whole to the power x by 2 by 3x plus 2 whole to the power x by 2. So if I take 3x to the power x by 2 common, what we are getting, that is 1 minus 1 by 3x whole to the power x by 2 by, if we take 3x to the power x by 2 common, we are getting 1 plus 2 by 3x whole to the power x by 2. So 3x, this portion, this part is getting cancelled, and we are getting 1 plus fx whole to the power gx, e to the power fx into gx. So if I calculate here directly, I can calculate it. Acha, okay, first of all, let us solve the sum. Limit x tend to infinity. So 2x square minus 3x plus 5 into 1 minus 1 by 3x whole to the power x by 2 total divided by 2x square. Sorry, here it is 3x square plus 5x plus 4 into 1 plus 2 by 3x whole to the power x by 2. Now just see one thing, in this case the maximum power in these two polynomial in the numerator denominator, the maximum power should be x square. So let us divide by x square. Let us divide by x square. So in this case x square, just let us divide by x square. Everybody, these type of sums are very repeated for the exam, so must ready with this type of sum. So this is multi x square. So 2 minus 3 by x plus 5 by x square. Similarly denominator also 3 plus 5 by x plus 4 by x square. So okay, since x tend to infinity, therefore 1 by x square is coming to be 0. And in this case, all this case 1 plus fx whole to the power gx ka form. So directly I can put here e to the power fx into gx. So e to the power x by 2 e to the power x by 2 into minus 1 by 3x. Denominator is e to the power x by 2 into 2 by 3x. So final answer, all this portion is coming to be 0. So here it is coming 2 by 3, and e ka power, if we calculate, we are getting 1 by root e. So final answer, what is coming here? answer we are seeing that the final answer is coming option B. Now next sum. So in this case, this is another type of frequent sum, sometimes coming in continuity differentiability, this type sum, sometimes coming in function. So here it is the limit, obviously. So this, how to solve this type of sums? First of all, by seeing the sum, we have to identify exactly what we'll do. So here you see if r minus 0, it means it is a domain, this is a range, the function such that f of this calculation, whenever this type of sum is there, everybody will just try to replace, try to get the fx. So I am writing here, so fx minus 6 f of 1 by x equal to 35 by 3x minus 5 by 2. Now putting x in replacing x in terms of 1 by x, so f of 1 by x minus 6 fx equal to 35, x का जगह पे 1 by x, x की जगह 1 by x minus 5 by 2, and if we solve it, by solving this we are getting fx equal to minus 2x minus 1 by 3x plus half. This is a calculation. Now beta equal to what is given? Limit x tend to 0, 1 by alpha x plus fx. So we can say here limit x tend to 0, just putting the value of fx here, 1 by alpha x minus 2x minus 1 by 3x plus half. Everybody understand one thing, if I take the 1 by x common here, limit x tend to 0, 1 by x common, so 3 minus alpha by 3 alpha, and separately it is coming to be plus half. Now this is equal to beta is coming, this is equal to beta is coming. Now this is 3 minus alpha should be 0, otherwise denominator should be this is coming infinity, so 3 alpha should be 3, and automatically beta equal to half. Therefore alpha equal to 3 and beta equal to half. This is the thing, and finally our target is to get, what is the target? Target is to get alpha plus 2 beta. Therefore I am putting here alpha plus 2 beta. Therefore alpha plus 1 minute, are you ready? Therefore alpha plus 2 beta equal to what is coming to be here? 4. Okay, now I'm going to the next sum. This type of sums, everybody, can you remember where you have seen this type of sums? Whenever you'll see, this is nothing but the telescopic series, and nowadays this is the trend in JEE examination. Just in last 1 year, 1-2 years, that telescopic series application was previously limited to the sequence and series, but nowadays questions are coming on telescopic series. Okay, so let's solve it. So what we'll do here, first of all, in this case, everybody, whenever cubic equation, that is k cube plus 6k square plus 11k plus 6, you have to identify, remember this is coming to be k plus 1 into k plus 2 into k plus 3, this you have to identify. Okay, so let's start solving the sum, and we have to apply the telescopic series method. So first of all, limit x, here it is n tend to infinity, sorry, it is n tend to infinity, limit n tend to infinity. So in this case, summation of k equal to 1 to n, that is k cube plus 6k square plus 11k plus 6 minus 1, because first 4 terms will give you the k plus 1 into k plus 2 into k plus 3. So I am writing here. Now just I am separating. So limit n tend to infinity, summation of k equal to 1 to n. So in this case, k plus 1 into k plus 2 into k plus 3. So in this case, minus 1 by k plus 3 factorial. Main target is the cancellation method, whatever we say that, and that British are telling that British are telling this thing as the telescopic series, and we say this as a cancellation method. So now we can write this as limit n tend to infinity, what we'll do here, summation of k equal to 1 to n, what we are getting, just a minute, so 1 to n, I'm just putting here 1 by k factorial minus 1 by k plus 3 factorial. It's a very nice question, everybody. This question is very nice question. You notice one thing, then it will be easier for you to understand. So in this case, what I'll do this, limit n tend to infinity. Generally in the telescopic series, in general telescopic series means हम लोग we have the idea on that this is the sequence and series question. But here you see one thing, in telescopic series what we do, that terms, if you add, all terms are getting cancelled remaining first term and last term. This is a general rule, but sometimes in the examination they are giving that they are just making one trap here. You see one thing, if we put k equal to 1, we are putting 1 by 1 factorial minus 1 by 4 factorial plus 1 by 2 factorial, k equal to 2, 1 by 5. Just you see one thing, there is no matching. Now we have to put k equal to 3, 1 by 3 factorial minus 1 by 6 factorial. Now put k equal to 4, there is no matching and they are not getting cancelled. And here everybody, here students are getting confused. In this situation, students are getting confused that am I doing the right way? So just in this type of cases, you have to just proceed with something. Okay, I have more and more terms. Now we are getting what? 1, 2, 3, 4. So 1, k equal to 1, 2, 3. So put k equal to 4. If we put k equal to 4 here, we are getting what? 1 by 4 factorial minus 1 by 7 factorial plus, then also I am not getting something, yes, 1 by 4 factorial is getting cancelled. Then also one more time I am putting. So 1 by 5 factorial minus 1 by 8 factorial. Okay, if we just go to the cancellation, you see the type of cancellation is this. 4 factorial is getting cancelled from here. This is a 5 factorial. Now remaining terms are very important, that is limit n tend to infinity. What we are getting, 1 plus 1 by 2 factorial plus 1 by 3 factorial. Final answer is coming to be 5 by 3. Okay, so in this case answer is coming to be option number A. And in this case, everybody, this is nothing but a trap, because just generally what happens in the exam hall ka jo mentality in this case, so you'll be afraid if the after getting some terms they are not getting cancelled. So acha se sum solve karna. Let us go to the next sum. This is one more question, everyone, and for this type of questions I have discussed previously also, so I am not going to this sum. I have discussed this sum previously number of times. So this is another question, and nowadays you see one thing, this series type of sums are very frequent and you have to solve very fast when you see these type of sums within 3-4 stage. Just I am explaining you. I am writing the sum first. First I am writing limit x tend to 0, 3 plus a sin x plus this is alpha, sorry, this is coming alpha, this portion is coming to be alpha sin x plus beta cos x. So it seems total series we have to apply, and log of 1 minus x total divided by, we are getting 3 tan square. So remember one thing, so in this case tan square x by x square we can put 1, tan x by x to 1, so tan in the product form we can put this to be 1. Now let's start solving the sum, that is limit x tend to 0. I am using directly the series formula. So 3 plus alpha sin x, the series of sin x is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial up to infinity, plus beta cos x 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial, continuation, plus log of 1 minus x is minus x square by 2 minus x cube by 3, continuation, total divided by denominator x square. Remember one thing, everybody, denominator x square and limit is coming 1/3. This limit is given to be 1/3 and denominator is x square. So there is the problem is that that this denominator is x square and limit is the finite limit. Since limit is the finite limit, the target should be single power of x should be 0 and x square which will be remaining. Answer is coming 1/3. That should be our main problem solving strategy. So what I'll do this, just simple, the power of x is search here. This is 3. Single constant power. Yes, right. One more thing is that I forgot to tell you, that's a constant power, and single power of x, it should be coming 0. So what is the constant power? This is 3 and this is beta. So 3 plus beta is coming 0. And what is the single power? If we see here, what is the single power of x? This is coming to be here, everybody. This is alpha. This is single power of x, alpha. And one more thing, single power of x is, this is -1. Okay, this is single power of x. This is a single power of x. Therefore, this is -1. Now I am just making a constant power as 0. So 3 plus beta equal to 0 and alpha minus 1 equal to 0. So beta alpha equal to 1 and beta should be, what is there? -3. What is the target for us? That is 2 alpha plus beta. Not very hard sum, everyone. But nowadays, the series based questions are regularly coming. So be ready with this type of sums. So we are getting 2 alpha minus beta. So 2 into 1, that is 2 minus beta, that is coming to be 5. Therefore, everybody, the final answer is option number A. Now I am going to the next sum. So remember one thing, mod, box, fraction, root. These are the main part for the entrance examination. So let us solving. So in this case, what we'll do? Since it is a mod, so we'll write plus and we'll take plus and minus part. So x greater than 0, x less than 0. That is very much important. And so let us start. First of all, right hand limit. If we apply the right hand limit, so limit x tend to 0 plus, so all mod becomes positive. So e to the power 2 sin x minus 2 sin x minus 1 total divided by x square. This is coming. So now I am applying e to the power x formula in terms of e to the power sin x. So what is coming here? That is limit x tend to 0 plus 1 plus x. X ka matlab here 2 sin x. So 1 plus x. So 1 plus 2 sin x plus 2 sin x whole square by 2 factorial. Continuation minus 2 sin x minus 1. Denominator is coming to be x square. And we are seeing that 2 sin x plus 1 is getting cancelled. And now what we are getting? It is coming to be limit x tend to 0 plus, if I take 4 sin square x by 2 factorial, common 2 factorial means 2, that is coming 1 by 2 factorial plus higher power, higher order containing x, and denominator is coming to be x square because sin square x by x square is 1. So higher power all are 0. It is coming to be, everyone. So finally we are getting what? That is 4 by 2. This is coming sin square x by x square. So in this case, this is coming 1 and this is 4 by 4. And one more thing, is there anything else? 4 sin square factorial 2, 1 by factorial 2. And finally we are getting answer to be 2. Finally we are getting answer to be 2. And now I am just putting next portion, that is left hand limit. So if we write left hand limit also the same thing. So mod function is a negative function. Instead of mod we'll write minus sin x. So if I put the value minus sin x, what we are getting here? Just see one thing. 1 minute. This is 4 sin square x by 2. Yes, this is the thing. This is the thing. Now, left hand limit I am writing here. Limit extend to 0 minus. Now, same thing will be coming, that 4 sine square x. If I take common, I am not writing so much. You can understand this. 1 by 2 minus all higher power containing x. So all are coming 0. Answer is coming 2. So right hand limit equal to left hand limit equal to 2. So the final answer is coming. This is D. So remember one thing, everyone. Generally, previously, before 2020, all question was coming to be none of these. There's a option none of these. So I used to tell the students that whenever mod box fraction root is there, 99% case it is none of this. Further you check it. But now it is none of these options are not coming. Let us do this sum. This is another frequently coming sum. It's a very everybody repeated sum. This sum is the repeated question. Number of times this type of sum is repeated sums, so must practice all these sums. 1 to the power 1 by sine square x plus 2 to the power 1 by sine square x plus 3 to the power 1 by sine square x, continuation up to n to the power 1 by sine square x. Whenever this type of sum is there, so what we'll do, first of all, always we'll take that this portion outside. So whenever n to the power 1 by sine square x I am taking outside, it is coming out to be n, and finally we are getting 1 by n whole to the power 1 by sine square. I am writing cosec square x plus 2 by n whole to the power cosec square x dot 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 n by n. It means n minus 1 by n till this is coming to be cosec square x plus 1 whole to the power sine square x. So since a t tend to 0, this is x or t. Sorry, I have written it is x. I have written this as the x. So I am writing taking in red. Instead of t, I am writing x. Similar, same effect. So 1 by n, that is fraction to the power cosec square x, fraction to the power infinity is 0. This is 0. This is 0. Just 1 is remaining there. 1 to the power anything. That is 1. So finally, answer is coming to be n into 1. That is coming to be n. So this is option C is the right answer. So everyone, this type of sum also very frequent and repeated question. So this type sum, what we'll do? So there are a number of ways to solve the sum. I'm just solving in by series, because whenever you'll use a series, sum becomes very much comfortable for you. Okay, so let us start solving the sum. First, I am writing the series. I am writing the sum. Limit n tend to infinity. So if I take n square root over, see this, if I take root over n square common, so it is coming out as n. So n, I am taking n out, 1 minus 1 plus n by n square whole to the power half. Actually, it is you can use that binomial theorem of fractional index, plus n alpha plus beta. We need alpha plus beta. We need alpha and beta. So we know that 1 plus x whole to the power n for fraction and negative index. We are getting same thing, same formula, but we can write like this. 1 plus nc1 x, nc2 x. Instead of nc1, I am writing n, nc2 का जगह पे n into n minus 1. But same thing, just I cannot write nc1 nc2 because nc1 nc2, for nc1 nc2, n should be positive integer. That is why I have written that, but the formula is same. N minus 1 by 2 factorial x square, continuation, it will go up to infinity. So limit n tend to infinity, I am writing here n into n into 1 plus nx, that is half into 1 plus n by n square. Okay, 1 plus nx, n is half here, 1 plus nx. Then what we'll do here, everybody, in this case n is multiplied, plus n into plus n into n minus 1. In this case, remember n is half. So half minus 1 is what? That is half minus 1 is minus half, minus half root factorial to x square 1 plus n by n square whole square and continuation. Okay, plus n alpha plus beta. You see one thing, everybody, in this case we are seeing that from all this terms terms are getting 0 because denominator is higher. I am multiplying by n. So limit n tend to infinity. Here it is coming n minus half 1 plus n by n plus all the term half into minus half. Half, I am not writing so much calculation. Is not needed because this term already it will be cancelled. N square by in this case 1 plus n whole square by n cube. So all the time is coming to be 0 because denominator is more n 10 to infinity equal to, and finally we are given that this is coming to be 0. This is coming to be 0. So limit n tend to infinity and n minus half n by n is 1 and 1 by n is coming 0 and plus n alpha plus beta. Okay, why I am telling this? You see one thing, in this case 1 by n, 1 by n is coming out and that is coming to be 0, and n by n is coming 1, that is half is coming here. That is a target for us, and equal to 0 given to us. Now we can say n minus half. See this here. I am taking in this case what can be done. I can take n common, 1 plus alpha plus beta minus half. It should be 0. Remember one thing, to make it n tend to infinity, to make it 0, it should be first 1 plus alpha should be 0. Otherwise it will go to the infinity, it will go towards infinity. That is why 1 plus alpha equal to 0. So I can write here that 1 plus alpha equal to 0, and accordingly beta minus half equal to 0. So alpha equal to minus 1 and beta equal to half. Now what is getting, final answer should be what? 8 into, final answer is given to be 8 into alpha plus beta. So I am putting here 8 into alpha plus beta. Therefore 8 into alpha plus beta, that is 8 into minus 1 plus half, that is coming to be minus 4. So option number is what? Option number is C. Okay everyone, let's go to the next sum. This is another very good sum and repeated question, and very important sum for everybody. The type of questions are coming nowadays in JEE examination. These type of sums are very important. So let's solve it. So in this case, what we'll do, that the value of n tend to infinity 6 10 within the tan, this is theta, actually this is tan theta, this is theta, this calculation is theta. So how we'll proceed, just see. In this case, just first of all I am writing the term limit n tend to infinity 6 tan summation of r equal to 1 to n, summation of r equal to 1 to n, tan inverse, everybody see this. This is also telescopic series. By seeing whenever, wherever this type of term is there, remember it is nothing but the telescopic series, and you have to express as tan inverse A minus tan inverse B. So tan A minus tan B by, that is A minus B by 1 plus A into B. So denominator right left hand corner there should be any 1. So accordingly we'll suggest here, we'll just make our target. What to do here? Just see one thing. First of all, denominator I am writing 1 plus r plus 1 into r plus 2. So I am writing as a difference of r plus 2, r plus 1, and it is just matching. It is getting matching. So our main function, main work is done. Now I can use the telescopic series directly. So first of all, let us separate. So 6, 10 summation of r equal to 1 to n and tan inverse r plus 2, because tan inverse a minus b by 1 plus ab, that is tan inverse a minus tan inverse b, tan inverse r plus 1. You see one thing, everyone, nowadays number of questions they are using this telescopic series, which I am telling you repeatedly. That is finally what we are getting. If you put r 1 2 3 4 within angle and 10 to infinity 6 10, so what we are getting, we are getting first term and last term will be there. If I put r equal to 1 2 3 4, acha, I am putting here r equal to 1, that is 2, minus r equal to 2 tan inverse 1, plus r equal to 1, this is coming, sorry, if you put r equal to 1, this is coming tan inverse 3, r equal to 1, this is tan inverse 2. If we put r equal to 2, this is coming tan inverse 4 minus tan inverse 3. So continuation. So remaining first term and last term, because they are getting cancelled, not like that previous question which you have solved. So 6 10. In this case, finally is coming what? First term and last term, tan inverse r plus r equal to n. Finally we are putting tan inverse r plus 2 minus tan inverse 2. So limit n tend to infinity, we put n equal to infinity, we are getting what? That 6 10. So tan inverse infinity is pi by 2. So pi by 2 minus tan inverse 2. Tan inverse 2 is okay. Tan 90 minus theta cot theta, that is tan inverse 2 means cot inverse half. So 6 tan 90 minus theta cot theta, that is cot of cot inverse half. I am writing here, this is the cot of cot inverse x means x. Answer is coming 3. So everybody, whenever this type of questions will be coming, this is under the easy sum, under the case of easy sum, because in previously number of sums in PYQ, in previous year examination, question came on this type. So this is categorized as the easy sum. This is the easy sum. Okay, I am going to the next sum. This is another very good sum. How to solve this sum? So in this case, it seems that this is tan x by x is 1. So 1 to the power, this in the form of 1 to the power infinity. This sum is in the form of 1 to the power infinity equal to p. So this is everybody, it is nothing but easy question. So what we'll do here in this case, what we'll do, 1 plus fx whole to the power gx of formula. So given p equal to limit x tend to 0 tan x by x whole to the power 1 by x square. So we can write this as 1 plus tan x by x minus 1 e to the power fx gx of form. It means 1 plus fx whole to the power gx. So e to the power 1 to the power infinity e to the power fx into gx. So thinking this in mind, I can write this as p equal to limit x tend to 0 e to the power fx into gx. It means tan x by x minus 1 into 1 by x square. So just direct value, directly calculation if we do this. So tan x minus x by x cube. Now I can do one thing, we can do two things. One is the directly L'Hopital's theory, or other cases we can use the simple series. Series is better. So we can write this as limit x tend to 0 e to the power tan extra series 1 x tan extra series, what is there? That is x plus x cube by 3 plus 2 x to the power 5 by 15 continuation, total minus x, total divided by x cube. Just see here, in this case x is getting cancelled, and if we take x cube common, so e to the power 1/3 and all higher power is 0. all higher order is coming to be 0. So answer is coming e to the power 1/3. If it is e to the power 1/3, therefore what is getting, what is been given here, given 96 log p. So how to find 96 log p? So 96 log p log e to the power 1/3, that is 96 by 3, that is coming to be 32. So answer is here, everybody, is coming 32. Okay, let us go to the next sum. This is another very good sum, and in this case we need the formula of the trigonometry. And remember one thing, always for calculus, to make the calculus very successful, you have to know the multiple and submultiple angle, which is extremely important. Everybody. So let's apply this sum. In this case, it has been given that fx equal to limit n tend to infinity and r equal to 0 to n. So what we'll do here? So tan of, okay, I am writing first. Let's write first. So fx equal to limit n tend to infinity, r equal to 0 to n, r equal to 0 to n. So tan x by 2 to the power r plus 1. I am taking 2 tan minus 10, so that we'll get the direct formula. And everybody remember, you have to get totally very much comfortable with the multiple and submultiple formula, then only your calculus will be very strong. Otherwise you have to suffer in calculus. So 2 tan x by 2 to the power r plus 1 minus tan x by, remember, tan x by 2 to the power r plus 1, I am writing 2 tan theta minus tan theta, that is tan x by 2 to the power r plus 1 plus here tan cube x by 2 to the power r plus 1 divided by 1 minus tan square x by 2 to the power r plus 1. So what we'll do here now, limit n tend to infinity. So I am writing here summation. I am separating 2 tan theta by 1 minus tan square theta, tan 2 theta ka formula, tan x by, I am separating, everybody, I am separating from here because this is the formula of tan 2 theta. That is the reason. So 2 to the power r plus 1 total divided by 1 minus tan square x by 2 to the power r plus 1. Okay, and I'm not giving the bracket here. And finally what we'll write, minus, if I take tan x by 2 to the power r plus 1 and 1 minus tan square x by 2 to the power r plus 1 by this is coming what, 1 minus tan by, similarly it should be cancelled, tan square x by 2 to the power r plus 1. So finally what we are getting, everybody, this is getting cancelled, and this portion is 2 tan theta by 1 minus tan square theta. This is the tan 2 theta formula. So I am writing this as limit n tend to infinity. This is coming in limit n tend to infinity, tan 2 theta, the summation of r equal to 0 to n. So tan x by 2 to the power r minus tan x by 2 to the power r plus 1. Again and again, this is nothing but the telescopic series. If you put the value, we are getting tan x. You must practice all these type of sums because this is very important. Now finally we are getting fx equal to tan x. Finally we are getting fx equal to tan x. So if we get fx equal to tan x, then what is the final answer? The thing is that we have to do this limit, we have to apply. And everybody remember, whenever we'll get the opportunity to use the formula, this is the best. Therefore we can write here limit x tend to 0 e to the power x minus e to the power tan x by x minus tan x. So I can take e to the power tan x common, limit e to the power x minus tan x We are getting x minus tan x also tend to 0 as x tend to 0. So I can write here, this is coming to be, this portion is coming to be 1 and e to the power 0 means 1. Final answer is coming to be 1. So this is coming to be 1. And this is another very good summary. In this type of cases, here it has been given that limit x tend to 0 plus. Limit x tend to 0 plus. Since it is a x tend to 0 plus, therefore we can write that we know that x plus x minus box x equal to fractional x. It means x equal to box x plus fractional x. That we know. That we know. Therefore, what we can do in this case, wow, just one term I am showing you. Just see, box of 1 by x equal to x minus fractional x, or box of 1 by x square equal to x minus fractional 1 by x square. This is 1 by x square. And if we write that, just I am writing rough, limit x tend to 0, x into, just see, x into box, just one term I am showing you, then it will be repeated. That is x into box of 1 by x means 1 by x square. So 1 by x minus fractional 1 by x. So this is coming to be x into x is 1 minus x into fractional 1 by x, and this portion is coming 0. Therefore, we can write this as, now I'll just go to the fair part. So finally we are getting what? This is coming 1, this is coming 2, this is coming p. Similarly, x square, this is coming 1, this is coming 2 square, this is coming 9 square. So finally the result is coming to be p into, I am writing in some details, 1 plus 2 plus 3 up to p, because once again I am telling you what is the reason behind it. Yes, the reason is that x into fractional 1 by x, x tend to 0, fraction lying between 0 and 1. So this is coming 0. So this will be there. So we can write here plus, I can, sorry, it a minus. We can write here 1 square plus 2 square up to p square. And it has been given p into p plus 1 by 2 minus 9 into directly Epica formula, 9 into 10 into 19 by 6 greater than equal to 1. It has been given here. We are given that this is greater than equal to 1. Now we'll proceed. And p into p plus 1 by 2 greater than equal to, that is 10 into 9, 19, that is 6, 15 into 19, that is 285. So you have to calculate very fast. 285 plus 1. So p into p plus 1 greater than equal to 572. Just greater, sorry, it is 572. Just greater than 572. See this, just greater than 572. What is the product of two numbers? And remember, everybody, this is 24 into 25 equal to 600. Therefore, just greater than 572, that is 24 into 25, and p is the 24. Therefore, p should be minimum value. P should be 24, and sum is coming to be 24. So everybody, these are very important questions and repeated questions, and next I'll come with the more and more chapters. Mainly target should be calculus. Okay, bye everyone.